All right, welcome back to another episode of Science with Surback. Today, what we're going to talk about is section 11.1, and that introduces what we call the chemical mole. Now, before we get going in notes, I want to outline a couple of objectives that you should be able to meet by the end of this video. Objective number 1, describe how a mole is used in chemistry. Objective number 2, relate a mole to common counting units. And objective number 3, convert moles to number of representative particles and number of particles to moles. So let's go ahead. We're actually going to get back into a little bit of review about the atom, and we're going to talk about the size of the atom. So remember, individual atoms, molecules, which are covalent compounds, or what we call formula units, which are ionic compounds, are really, really small. So again, molecules, we can call them as covalent compounds, and formula units we can just refer to as ionic compounds. Now, to give you an idea of how small an atom is, or these particles are, each individual component here that I just outlined ranges from about 0.1 to 0.5 nanometers in diameter. Now, just to give you an idea, a nanometer, we can fit 1 billion nanometers in one meter. Again, 1 billion, that is a lot. 1 billion nanometers in 1 meter. So they're really, really small. And remember, we can't see with our, just using our eyes, we can't see how small these atoms are. We can't see them at all. Now, since one atom is so small, chemists need a convenient method to accurately count the number of atoms, molecules, or formula units of a substance. So what chemists do, quite a number of years ago, like a couple hundred years ago, they developed a system to be able to count these particles, and not individual particles. Remember, they're really, really small, so it's not like you can take a set of forceps and pick out the atoms. What they did is they counted these particles in a way or in a unit known as the chemical mole. So again, atoms, formula units, and molecules are really small, so we need a method to be able to count those in a really convenient way, and that's known as the mole. So what we can transition to now is the specifics about the chemical mole. So if we shift gears here, the chemical mole is the SI base unit used to measure the amount of substance. Now, specifically, 1 mole is the amount of atoms in 12 grams of pure carbon 12, or its equivalent to 6.02 times 10 to the 23rd atoms of that carbon 12 isotope. Now, again, 1 mole, and we'll emphasize here, 1 mole is equivalent to 6.02 times 10 to the 23rd particles. And if we want to put it in perspective here, 1 mole is really similar to a word like dozen, which dozen is just another word for saying we have 12 of something. Whereas a mole, if we say we have a mole of something, we have 6.02 times 10 to the 23rd of that something. So we have a lot of that something. Again, a mole is just a convenient way to say we have 6.02 times 10 to the 23rd of our something. Very similar to the word dozen. Now, if we get a little bit more in depth and detail here, this 6.02 times 10 to the 23rd, what that is actually called is Avogadro's number. Now, Avogadro's number is a very large number that is used to count the extremely small particles of atoms, molecules, or formula units. Now, what we do with Avogadro's number is it allows us, this Avogadro number allows us to conveniently measure substance in a chemistry lab. Now, it's not an easy way to count by number of atoms. So if we have Avogadro's number, it makes it a little bit easier for us to actually count things fairly simply in a chemistry lab. So now, we can go back and forth between moles of a substance and particles of a substance. So what we're going to do now, we're going to transition to how we convert from moles to particles of a particular substance. So we'll transition here and we will get into our steps. So I like to outline steps here of how to solve. And so to go from moles to particles, the first step is write down the number of moles given to you in the problem. The second step in this process is to set up the conversion factor, which the conversion factor is going to have 6.02 times 10 to the 23rd representative particles per 1 mole. And then I also want to stop and pause here. Mole, for whatever reason, when they abbreviate, they chop off that E. And so you'll see mole written as M-O-L-E. And more often than not, to save some space, we just put M-O-L. So both of those things mean the same thing. And then the third step is to just calculate. Now, we've talked about particles, and particles aren't typically going to be your unit. So the fourth and final step is to determine your unit. So if we only have single elements, the correct unit is atoms. If we only have covalent compounds, the correct unit is molecules. And if we have ionic compounds, the correct unit is formula units. Okay, so let's put this knowledge to the test here in an example problem. So we want to determine the number of atoms in 3.75 moles of Fe. So the way we do this is whatever number is given in this particular problem, we always write that down first. So we have 3.75 moles of Fe. Now it's really important to not only include that unit of moles, but to also include what substance we're dealing with. That helps make the correct unit at the end a little bit easier process. Now what we do is we set up that conversion factor. And remember, we want diagonal units to cancel out. So because we have the units of moles, Fe, and we want to cancel that diagonal, we put moles of Fe on the bottom. And then on top, the problem helped us out here, and it said, hey, go to number of atoms of Fe. So we can go from moles of Fe to atoms of Fe. And then the way we get our number here, the way we get our number for this particular problem is we look here. 1 mole of anything is equal to 6.02 times 10 to the 23rd particles. Now because we're dealing with a single element, that is why we have the unit of atoms. So again, 1 mole is equivalent to 6.02, so 6.02 times 10, and this is to the power 23. Okay, so how we do this is we plug this into our calculator as such. We have 3.75, so I type in 3.75. Then I multiply it by this Avogadro's number, and when I do that, I need to put a set of parentheses. That's going to be really key, especially when we have scientific notation. So I put in 6.02 times 10, caret symbol for the root, to 3. I got to close the parenthesis. I press enter, and then I divide the number on bottom. So I divide by 1, which it's obviously the same number here, and I'm going to round to 3 total digits. So my answer here becomes 2.26 times 10 to the 24th. So this becomes my answer, 2.26 times 10 to the 24th. And then remember, our units for an individual element is atoms of Fe. Okay, so we've gone from moles to atoms or particles. Now we can do the just the opposite. We can start with some type of particles and we can convert to moles. So let's transition here and we'll go over the steps first and then we'll go through an example. So we start out here. This is just the reverse process that we did. So number one, the first step here is to write down the number of representative particles given. And just as a reminder, remember, representative particles, if we have single elements, they are going to be in the units of atoms. Covalent compounds are going to be in the units of molecules. And ionic compounds are going to be in the unit of formula units. The second step is to set up the conversion factor. And remember, 1 mole is equal to 6.02 times 10 to the 23rd representative particles. Once you have set up that conversion factor, you simply just calculate. And then you need to put the correct unit, which in this case will be moles of the substance. All right, so let's put these steps to the test here in our final example for today. So we want to know the number of moles in 4.50 times 10 to the 24th atoms of Zn, or zinc. So what we do is we start out with what is given. Always make it easy on yourself. Write down exactly what's given. So 4.50 times 10 to the 24th atoms of zinc, Zn. Now, we set up our conversion factor. And I'm going to make this one a large conversion factor. And again, diagonal units have to cancel out. So because we have atoms of zinc, we need atoms of zinc on bottom. And up top, we are trying to convert to moles. And so we can put moles, and remember we abbreviate that as MOL, and we have zinc on top. Now, where we get our number is right up here in step 2. 1 mole of anything is equal to 6.02 times 10 to the 23rd representative particles. And remember, we're dealing with an individual element, so we call that atoms. That's why we placed atoms down below. So again, we have 6.02 times 10 to the 23rd atoms. And on top, we have 1 mole. So we have everything that we need to do our calculation, and so we'll get out our calculator. So parentheses are key. So we have 4.5 times 10 to the 24th atoms of zinc. So what we do here, we start out with a set of parentheses. So 4.50 times 10, caret symbol, to the 24th. We close that. We multiply it by what's on top, which is just 1, which obviously will get that same value. And then we divide everything on bottom, which in this case is just 6.02 times 10 to the 23rd. So what I'm going to do, I'm going to keep that answer of 4.5 times 10 to the 24th in my calculator, and I'm going to divide it by, very key, parenthesis, 6.02 times 10, caret symbol, to the 23rd power. You close the parentheses and you press enter. Now, I had 3 total digits, so I'm going to keep 3 total digits. So our number of moles of zinc in this particular problem is 7.48. So again, that rounds to 7.48, and that would be in the units of moles of zinc, Zn. And so that would be our answer. So I've shown you how to convert from moles to particles, and particles back to moles. I hope you have enjoyed this episode of Science with Surback, and as always, subscribe.